Hello, yeah, you can start now. I think last week we discussed about the classification analysis project. Classification project, the complete outline I gave it. Did anybody try to execute that project? Okay. Today we are going to discuss. Sorry, somebody is talking something. Yeah. Today we are going to discuss about regression project. So as I told you that you need to submit your project. So because of this pandemic and other things, we are only focusing one some teams, six teams will be do the classification project and six teams will done the regression project. So because of other things, we are not doing segmentation cluster analysis project. If anybody interested, you can do that later. So I explained the classification project complete process and gave the this thing also HTML and other thing also. Today I will explain about the regression project. Then if anybody has any idea to do the project own, welcome. You guys go ahead and do as per the code I have shared. Otherwise, if you want me to assign the project, I will assign some of the projects. Okay. So today what we are trying to do is basically today I am trying to outline the complete machine learning process for the regression project, regression analysis. What is the difference between regression and classification? In the regression, the dependent variable is the continuous variable. In the classification, the dependent variable is nominal variable or categorical variable. Last week we discussed one project where we try to predict the customer churn based on the other variables. There we have seen complete pipeline of the process. Today we are doing the same thing for the regression. So here the problem what we are going to solve is basically we need to predict the salary of the professors based on their rank, their discipline, years since PhD, years of the service, obviously based on the gender. So based on these five six variables we need to predict the salary. So as being salary is continuous variable, this problem falls under regression problem. Okay. As I told you that for any machine learning project we have a process. We need to read the data, we need to check that scale types properly, check for the missing values and outliers. We need to treat the outliers, try to find the interrelationship the variable, then try to create the before modeling we need to split the data into training and testing for the better generalization capability. Then we will run the regression techniques as a pipeline, and based on the accuracy we will take the decision. Similarly, that's what. So for that, what we are trying to do, first we are trying to import all the libraries. So these are all the libraries: pandas to read the data, numpy for manipulation, matplotlib for plotting, scikit-learn for machine learning, in which train test split function is used to split the data into train and test cross validation, and k-fold cross validation, grid search CVs parameter for hyperparameter tuning, and random forest. All required things I have importing here. That's what I have done it here. Then I am reading the data. We read the data by using read underscore CSV function. So the data I am reading is the final.tsv. Let me clear this and then. Okay. Now just read this data, read this thing. Then I am reading this data. So once I read the data, I am here also. Now each.ne basically will give the missing value. I am seeing the missing value, and as well as I am seeing the data set also. So I am doing so many things one place. I am just reading the data. Then let me see, is there any missing values are there. So there is no missing values. Yeah, before that we need to see the shape of the distribution. Shape is basically be the how many rows and columns. We need to see the whether data is read properly or not. So we need, that's why always once you read the data you need to print the shape and see whether all the rows and columns imports properly to the Python or not. That's what we need to check. So here is the 200 respondents and 6 variables. Now you need to go to raw data and see once again just whether all the records read properly or not. So we have 200 and 1 2 3 4 5 6 variables are there. So we are okay with the data. Now after reading the data we basically let's see, same, if you want to see the head is basically give the top 20 records. So here if you see the rank is basically a categorical variable, discipline is also a categorical variable, year since PhD is a continuous variable, Year service is basically continuous variable. Sex is basically a categorical variable. Salary is basically a continuous variable. So now for all continuous variable, what we do? We do the data dot description. I am just putting 2 as a decimal points. If I see this, for all the continuous variable, I will get the descriptive statistics like count, mean, standard deviation, mean, 25th percentile, 750th percentile, 75th, and maximum. For all the continuous variable, it came. Rank also taken as 1 2. Okay. Year since PhD, year since this thing, gender also taken, because it has 1 0. Actually, we need to convert this as a object. Actually, I will do that. Wait. How do we change this as object to what we need to say is basically data set of 6 as type equal to data set of say as type object. So now if you say data dot types, it should be like, see, now this become objective. Similarly, rank is also we need to make as objective, because rank is a categorical variable, no? So same thing, if you do, this is what we can change the rank as object to So if you do rank as object to, now if you see rank is also object to came. Now we have done the properly. Now if I say description, now it won't come. Now we will get only for these 3 variables. What is that? Year since PhD is a continuous variable. Year since services, because we can only do the descriptive statistics for continuous variables. Okay. Now what I am trying to do is basically I am trying to find the correlation also between the variables, these 3 variables. If you see, if I say the correlation, only the continuous variable it will get. That's what, type is very important. If you don't change the type here, even for gender and sex and rank also, you must get some kind of correlation, because Python doesn't know whether it's 1 0 is categorical variable or numerical variable. That's why you always need to change the type. That's why type is very important. So now, because I have done corrected scales properly, here in the correlation I am not getting those 2 variables. Clear? Now we seen that after that we need to understand the data by using descriptive visualization. That's why I am just putting histogram for all the variables. We have 3 variables. That's what this histogram. So here, since PhD is slightly positively skewed, negatively skewed, so this is what we can see the data using the descriptive statistics. Now let's see the scatter plot also, because once you treat the scales properly, it will take. So scatter plot is basically year since PhD. This is what year since PhD versus years of service correlation. This is how we can see the interrelationship between the variable using this plot. Now we are seeing, is there any missing values or not? So that's what, there is no missing value. In case of any missing value, the following lines will give the code snippet to replace the missing value. In case of your missing value is for continuous, we will replace them with median. In case of your missing value is the categorical, we replace them with mode. Okay, right now we don't have anything, that's why we are not doing anything. So then what we need to do next, we need to see the, is there any outliers or not. How do you find the outliers? For outliers, we have one method called box plot. So that's what I am doing, this box plot for this thing I am doing. So do you have any outliers? Yes, there is an outlier. So now how can we remove the outliers? We already discussed, if the outliers is above the whisker, we need to pull back this data into 95th percentile. If it is the bottom, we need to put it in the 5th percentile. Now the outliers is in which side? 95th side. So we need to make this as a 95th percentile. So that's what I am doing. Data set that location of data set salary is greater than data set that quantile of 95th. So if it is more than 95th percentile, then put that value into 95th percentile. That's what I am doing. After that, just I am printing this. So there is no outlier. So we are removing the outliers also. Then similarly we need to do it for years of PhD. There is outlier. Similar all the
Sir, Holgate idea? It is 95.
That's the common practice 95. Hello. That's the common practice generally people will do. Okay.
At 95.
Yeah, at 95th percentile. If it is at bottom side, then 5th percentile. Okay. Then similarly, if now we can see the even years also at the positive side, 95th percentile. Same thing we are doing this. Then if you see that outliers must have gone. Then similarly for years of service also, I think there are two outliers because possible because some people were very sick. This is just give you a process, guys. You need to do it. Actually, learning data science is nothing but doing data science. Hardly we can't see our faces also. Hopefully, we can meet at least at the time of exam. So now this is what now we are seeing years of services. So we have removed this outlier. So this is the process you need to follow. Once you remove the outliers, now you need to see the is there any relationship between these three variables. Obviously, salary and service could be correlated. So that's what we are seeing the correlation. Because how do you find the relationship among the continuous variable? If you want to find the relationship between the continuous variable, we will do the correlation. The same thing here we are doing. So if you see, this is what correlation. So years of PhD is this color is basically high correlation. This is high correlation. Years of service and salary moderately, it's not high correlation is there. Some kind of correlation is there. That's what we can understand. Now, as we know that we have two other variables also. What they are, sex and rank. So they cannot be what discipline. Sorry, it's the discipline and discipline. So obviously they cannot work on the text, continue this data. So what we need to do, basically we need to convert them into the numbers because they cannot, that variable has letters now. So letters means like ABC. This discipline is basically then ABC. So computers cannot understand. That's why what we can do, we can do the label encoder and we can create them into the groups by using the label encoder. But label encoder is what we are doing. We are just converting that variable into numbers. So if you print now data set, that ABC will be converted into the now you can see this becomes like 1 2 3. So what label encoder will do, it basically will give the different numbers 1 2 3. Now discipline 1 2 3 is also basically categorical variable. So here actually there is a small logic. Sometimes people will convert them into label encoder, and if the labels have some kind of inherent order, they will consider that as it is and use it. For example, poor, average and excellent is there. They don't need to create a dummy. They can still use that kind of relations and build the model. But but the standard practice is any categorical variable, you first convert them into label encoder and do the dummy variables. So don't use label encoder itself, use the label encoder, then try to use the dummy coding. All the categorical variable, continuous variable, categorical variable should be converted into the dummy variables at any cost.
Sir, what's the difference between label encoder and object?
Object is basically categorical variable. Object is the type. We are telling the let's say sex male and female. When Python reads sex variable as male and female, in the type becomes the objective type. So we are telling compiler that it's a objective variable, but it will read then a male and female. But when you are building the model cannot read M and F because they are numbers. Now you need to convert that MF into numbers, creating some kind of labels like nominal scale. So that's where we are using the label encoder and converting male female as 1 2. It's basically assigning some kind of scale. Okay. So now discipline I have converted, then I am seeing is there any relationship between the discipline by salary. Actually it should be reverse. 1 minute. Here it should be salary, it should be discipline. So this is where we can see. Now we will see is there any relationship between the salary. Yeah, obviously I think 0 and 1 has high salary. Maybe these are some kind of experience, some kind of discipline. I don't know what is that, but they are significantly higher salary than the people who has discipline is the 0. Okay. Similarly, let's see is there any relationship between the salary by sex. I think there must be no difference. Yeah, still there is also some kind of difference is there in the data. Anyway, this is what we will see, the relationship between continuous versus continuous, continuous versus categorical. Then I just put in the data set. Now what we need to do is basically, now we need to basically, because already we are not creating any dummy variables, because this discipline is already 0 and 1, and sex is also like 0 and 1, so we are not doing anything. So what we are trying to do is basically, we are just making x equal to minus 1. So x equal to minus 1 means last one, except last variable, consider everything as an input variable, and y is basically last, this one, consider the fifth variable as dependent variable. And here what we are trying to do, x colon 1, the first variable rank, actually we are basically convert them into this thing. Let's see, I will show it. Now if you say extra dot shape, okay, so what we are trying to do here, basically see, yeah, actually we created label encoder there. So what we are trying to do, we are creating x and y, we need to specify the x and y variable, except last variable, all other variables we are creating as x and rest variable as y. Then in order to do the validation, we are splitting the data into training and testing. Training data we are putting x underscore train, and completely validation data we are putting on x underscore validation. Similarly y variables also, that's what we have done. So we took 160 people as train, and rest of the validation, rest of the people as validation. Out of 200 people, we are taking only 160 variables, and training the model and do the cross validation with those 160 variable, and finalize the model, then use these 40 variables on that model. That's the plan. So now how to run the model, as I told you that now we are doing k, here we are doing k cross validation with 10 folds. And actually, when it comes to the classification problems, we use the accuracy. When it comes to regression problem, we use the mean square error. Okay, so that's what I put, number of folds equal to 10, cd equals 7. I am running logistic regression. Lasso is kind of regression, elastic net regression, I don't think these two are required because we didn't spend too much time. So what I am doing is, out of all the methods we discussed, what are the methods we have? Logistic regression, linear regression is basically equation, k nearest neighborhood is basically instantaneous based approach for regression, cart is basically rule based regression, support vector machines is basically layer based approach. So I am now running these 4 regression methods, and based on the results I will choose what is the best regression for this data. So that's what I am doing here, and that's what this code snippet will do. Then what I am trying to, I am saving all the results for these 4 models by using k cross validation. This function will give the results basically. So here you can see the methods, all the results scores. Then in order to see this value, you just compare the model on the test data. Now if you see, the error should be minimum. So which technique is giving better less error? So obviously the SVR is giving the this is giving less error compared to, so minus is, which is the highest error? Minus 1.4 is the highest error, minus 0.12 is the highest error. So negative minus is the small value, that's why this is the method we need to work with the SVM method. Now what we are trying to do, earlier we haven't done any standardization, because we have years of experience is there, that is one value, and like years of service is there, years of experience is also there. So we can also do the same thing by using the standardization. So what we are trying to do, we can also standardize the input data using this function. Actually it's not required actually, because they are on the same levels, but if somebody wants any other project, we can also do the standardization. Standardization means basically it is very useful when you have the different independent units at the different levels, it will help. So same thing what we are trying to do, the same pipeline we are running, but here what we are trying to do, we are basically standardizing the input variables. That's what we are running here. So earlier we haven't standardized the input data, here we have standardized. So still also SVM is giving fairly good fit. So now what we are trying to do, rescaled, I think rescaled is not required. So now this is what we will run the this thing. But even though if you run the SV support vector machines, it's very difficult to interpret it. So that's why what we are trying to do is basically wait, this is, oh god, I did something wrong here. Okay, leave it. Now what we are trying to do is basically so this is what how we can do the pipeline. But what we discussed it basically from what we are discussing from day one onwards is basically these methods is very difficult to interpret, which method SVM, and so that's why first we need to see fit the very basic model, that is a linear regression. So that's what here we are doing is basically here we are basically trying to fit the linear regression and see how much it is explaining. Okay, wait, let me, is the problem with this capital X, I think. Oh, wait guys, just wait, just give me X underscore train only,
Sir, in third line.
There should be a comma between X train and Y train.
Superman, great stuff. Still I am getting error.
Yes, second line. Sir.
Missing.
Model dot fit, my
Yes, sir. One open bracket is there, sir.
here also.
Yes, sir. Model, it is opening for model in third line and for extern also, but closing only one.
Great.
One more parenthesis.
Alright. Oh, Venu, what is happening today for you? Hey guys, wait. It's better to write model dot predict model dot fit. Wait. So now it's we fit the model. Now what we are doing? Predictions model dot predict bracket में model dot fit x underscore train comma y underscore train. So we need one more, na? No, model dot predict में you just need to say you already fit the model, na, x underscore train, then you will get the predictions. So that's why now these are the prediction. Now if you want to find the mean square error, this is what your mean square error. Okay, but you always obviously you need to find the R square also. To get the R square score, what you need to say, R square is basically regression, and R square is basically what you need to say y underscore validation and predictions. R square score, what it is saying, we got R square is not y underscore predictions, it's basically predictions, no? Y underscore validation, no, y underscore train only. I am not using validation. So I got 64% on the train data. Now in order to check the overfitting, underfitting, what we will do, we will do the same thing on the test data also, na? So that's what I will do. So predictions test equal to prediction test equal to model dot predicts, you can need to say y x underscore test. This is what test data, na? X underscore validation, sorry, x underscore, wait, x underscore x underscore validation, then train equal to y dot train. So what I need to say here, y underscore validation, correct, validation, then predictors test. So this will give the completely r square value and completely new data, correct. And let's see this thing, and similarly r score also. So that's what we will fit the standard regression equation. So this is what 59. So for test is a 58 and train is this. So this is how we will fit the linear regression individually. So just I showed how we can apply the pipeline there, but right now because of time, what you can do, you guys can fit only the linear regression. Suppose on the same data, if you want to fit the k nearest neighborhood, so we already discussed it. K nearest neighborhood is basically finding the near people. So what we will do, this is going to disconnect. Once we connect at 6:55, we'll do the k nearest neighborhood also. Okay guys, I will give the revised link. Quickly connect, I have a work. So we'll discuss k nearest neighborhood also, kn and regression also. Right, we discussed only linear regression. Understand?
Yes, sir. Okay.
Okay, right, we'll connect at 6:50.